This video is going to cover the topic of Introduction to Scale Graphing. Be sure the date and topic are at the top of your page. The essential question to guide the video will be, how do we use algebraic rules to change the size of an image on a graph? I'm going to show you what I mean with a very simple image. We're going to make a rectangle here, and I'm going to list the points for the rectangle below, and we'll graph them. And remember, of course, that when we graph, we use the x variable, right? The x coordinate to move horizontally, and our y coordinate tells us where to go vertically. So this first one is 1, 1. We go horizontally 1, vertically 1. Then we have 1, 3, 5, 3, and 5, 1. And if I make my lines as I go, I'll get a nice basic rectangle, right? Nothing too fancy there. So now I've set up a similar page again. I have a table here and I have my graph set up again, so you want to make sure you do that. And I'm going to start with my original points, the same that we had. So I'm going to fill those in. But now you can see next to it I have a different set of coordinates, kind of a rule that I have to follow to figure this out. So instead of having my values be the original x and y, now I see that I want my numbers to be worth 2 x's and 2 y's. Right? So that means I'm going to take whatever my x value is here and multiply it by 2. And I'll take whatever my y value is here and multiply it by 2. So for example, 1 times 1 would be, 1 times 2 would be 2. 1 times 2 would be 2. Right? On the second one, I have 1 times 2 is 2. 3 times 2 is 6. Next one I would have 5 times 2 is 10. 3 times 2 is 6. And 5 times 2 is 10, 1 times 2 is 2. So these are the new coordinates that I'm going to plot, and I'm plotting them based off the fact that I took my original and multiplied the x by 2, and I also happened to multiply the y by 2. So keeping that in mind, right, we would start at 2, 2. We'd go to 2, 6. We would go to 10, 6. Make sure I mark that correctly. And we would go to 10, 2, and I would make a rectangle. As you're making this rectangle, you should notice that it ends up looking just like the other one, it's just gotten larger. So I didn't change the shape at all, right? The shape has stayed the same, but of course this looks bigger, right? It looks bigger than the one that we did on the previous slide. So that makes sense, right? We multiplied both of our x and y values by the number 2, and it kind of just grew. Let's try this again, but with a different rule. So I still have a graph set up, just like we did before. I still have my same original coordinates, but now as you can see, the rule has changed. I now have x and then comma 3y. So that means my x is still the same, right? It doesn't look like it's being multiplied by 2 at all. So I'm just going to keep the x value the same. And the y value appears to be getting multiplied by 3. So that would look like, so 1 would stay the same, x is still x, but y gets multiplied by 3. 1 times 3 is 3. X will stay the same, but y gets multiplied by 3. 3 times 3 is 9. X stays the same, but y is multiplied by 3. 3 times 3 is 9. X stays the same, y multiplied by 3. So these are my new coordinates. And before I plot this, I'm kind of thinking to myself about what this shape will look like. Before, when we did it, on our second slide, we had the same shape, it just kind of grew. So I'm wondering if this will also stay the same. So kind of think about that as you're about to plot this. Go ahead and plot these points. I'm going to do the same and create the shape as you go, and then we'll see how it looks compared to the others. Here's what mine looks like. This looks pretty different. It's still a rectangle, right? The shape of a rectangle is still there, but this doesn't look like the original size or shape really anymore. It's the same width as it was, right? It still has the same width that it did at the start, but it looks a lot taller. And where the other one grew in both directions, this one only got taller. It didn't get wider. It's kind of stretched out vertically. And it'd be interesting to see if anyone can think about why that is, why the first one kept the same basic shape but kind of grew in all directions, and why the second one we tried when we did x3y totally got stretched out and it changed the kind of basic setup of the rectangle. It doesn't look like it is the same type of rectangle anymore. It looks more vertical, looks more stretched out. Here are the coordinates listed again that we did, but they're all in one place here now. So we have our original, right? And then we have our second and third rectangles that we made. And what we said was that these two looked similar, right? But one was bigger than the other, and the third one did not. And actually, we're going to use that as a term here, similar. That's a math term that we're going to talk more about, but I'm not going to define it here yet. I just want you to realize that these two are similar, and the third one is not. And what I want you to do before you come into class is to write down, why do you think the rectangles 1 and 2, right? This is number 1 and this is number 2. Why do you think we call these mathematically similar? Why do you think these ended up similar, but number 3 did not? So what do you think it means? I have a definition for you that I'll share, and we'll start playing around with this, but I'd like you to come up with an idea of what you think I mean by that and how you think that came to happen, why number 2 was similar, but number 3, let's call this one number 3, was not. And of course, the essential question for this video was just to see how we can use these algebraic rules, right? I just plugged in a value into a rule of like 2x, 2y, and I then was able to change the size of an image on a graph. This was just an introduction, so we're going to talk about it more in class. Be sure the date and topic, or excuse me, be sure to have your notes and any questions you might have in class tomorrow.